Okay, so when we talk about earthquakes, we need just a quick refresher on tectonic plates, right? Plate tectonics. We understand the Earth's crust is made out of plates. They move around. Should not be anything that is like mind-blowing to all of you. Remember that the continents move along with the plates that they are on, and that this process is slow but constant, right? That most of these plates are moving 3, 4, 5 centimeters per year.
Is that good or bad?
Well, good or bad is completely subjective, meaning like it's an opinion thing, right? Like, I think that metal music is good and pop music is trash, but some people would disagree with me. The rate at which the continents move is neither good nor bad, it just is.
It's just fine.
Okay, so this is kind of a fun map looking at the southern hemisphere with the South Pole at the center. Kind of fun. Anyway, and you can see the different plate boundaries, right? And we've talked about those. Let's talk about the plate boundaries in a little bit greater detail. All right. Where two more plates meet, this is a plate boundary. This should be familiar from the last assignment that we did. Several types of plate boundaries, different properties, and earthquakes kind of are dependent on these different kinds. Again, this is not so important for you to understand, but I do want you to know what a plate boundary is. It's just where two or more tectonic plates meet. Sometimes you'll have three plates that are all converging on one area. This is a plate boundary as well, in this image. So I think that it's super interesting because the tectonic plates are huge, right? They're these gigantic pieces of rock and metal. Well, we can see the division between two of them just in a picture. And this isn't like a huge cliffside. This thing might be 8 meters tall, maybe, like 20-something feet. These cliffs that go down into this river canyon situation. This is actually the plate boundary between the East Atlantic plate and the West Atlantic plate. And this picture was taken in Iceland. All right? So we just have this division. And this is interesting to think about because these walls, these cliff walls, while we can only see a little bit of the cliff wall, really you can think about these cliff walls as extending kilometers down into the ground. So if we were to follow this, it would be like a sheer cliff that goes all the way down to the bottom of the crust. Pretty cool. Cool. All right, so we have a plate boundary here. And this plate boundary specifically is a divergent plate. This again is actually the same plate boundary, just at a different place in Iceland. And here we have the two plates and they're pulling away from each other. So we have a plate on this side, on the right side, and we have a plate on the left side. And they used to be friends, but they're not friends anymore. Iceland, interestingly enough, is actually growing. Because as the two plates move away from each other, Iceland is a volcanic mountain, essentially, rising out of the ocean. And as the two plates move away from each other, Iceland will get wider and wider. Kind of a fun little thing to think about. So in a few 100,000 years, Iceland will be significantly larger than it is right now. So at a divergent boundary, the two plates aren't really interacting. They're actually just moving away from each other. So this doesn't really generate earthquakes at a large scale. Because nothing is rubbing against anything else. They're just moving away from each other. And I do say that they are usually small in comparison, in parentheses, because really any kind of earthquake is pretty big. We're talking about large pieces of rock shaking. Okay.
So is that one like an analogous where there's a pitch and there's two plates?
So yeah, so these two plates moving away from each other, they create kind of this, kind of like a ditch or a canal, right? It gets filled in, and these are sediments, right? Just like pieces of rock that have fallen into the division between the two plates. But these plates are moving away from each other, a couple of centimeters per year. All right? Divergent boundaries aren't all that exciting, in my estimation. I'll get to be a little bit more interesting. Convergent boundaries. Mountains occur when two continental plates converge, right? Anybody have a guess as to what this image is of?
Himalayas.
It is of the Himalayas. Anything specific about the Himalayas?
That says it right there.
Yes, this is Everest. This is Everest, probably the most famous mountain in the world. Yeah,
For a good reason.
yeah, because it's the tallest. So the two plates running into each other, they crumple, and they make these mountain ranges. When two continental plates run into each other. And remember that when a continental plate runs into an oceanic plate, it's different. But really, I just want you to understand the convergent boundaries, right? We'll talk about oceanic and continental convergence at a different time. Large earthquakes, they're common. Here's something kind of fun to think about. So because the continental plates are both crumpling, they crumple upwards, right? But they also crumple downwards. So you can kind of think of the Himalayas as being the upper part of this crumple, and then on the underside of the crust, there's like the anti-Himalayas. Right? They go down into the mantle. The crust goes up and down, so you get these different shapes. But like we on the surface only experience the upward part, right? But if you were able to go down into the mantle, you would see essentially these mountains that would go down into the mantle of the earth.
All the way up, just like what's the like far down mountains there?
Yeah, so these here, the subduction zones, the subduction zones can create these really deep, where the crust goes way down into the mantle, which is pretty crazy.
I have a question.
Yeah.
Do you like all the plates flat, or was it just all
That's a good question. So remember that the Earth formed when, with the rest of the solar system in a nebula, right? And so when the Earth was first forming, it was all molten. So it was a ball of magma, ball of lava, right? And as it cooled on the top, then it was mostly flat, right? And it was all just like basalt and all these different kinds of igneous rock. And asteroids and so forth were hitting this, creating mountains, creating these craters and so forth. But yeah, the Earth is eventually so there were no mountains from tectonic movement at the beginning because there hadn't been any movement yet. Yeah, good question. Okay. So quick questions about convergent boundaries. Mountains, this is not the only way that mountains are formed. Convergent boundaries, like we have mountains here. They were not formed by convergence. They were formed by a different process. We'll talk about that later.
Wait, why do you have to throw a slinky?
We'll talk about it.
Are we gonna play with slinkies?
I wouldn't say play with, but we'll demonstrate some
We're gonna make them
different
walk?
waves. Okay, so transform boundaries are when two plates are sliding past each other. And again, this should not be any news to you. We did an assignment on this. But as these two plates slide past each other, they are catching on one another. So they get stuck. They build up pressure and energy, and then they release that pressure and energy all at the same time. So at a transform boundary, you oftentimes get very powerful earthquakes. And this is an image here of the transform boundary. The boundary actually runs right this way, plate boundary. And what happens, so this river used to run straight. This river used to go straight through here, like this. Kind of the shape that my mouse is making here. Well, this side of the boundary is moving this way. It's moving up. And this part of the boundary is moving down. So the river used to be straight, but then the ground shifted. And as the ground shifted, it moved the river with it. Okay? Move the river with it. This results in large earthquakes, the shifting of transform boundaries. The San Andreas Fault, I'm not talking about the movie with Dwayne "The Rock" Johnson, San Andreas.
Oh,
There was a movie like 4 years ago. I haven't seen it. It's probably not very good. And I'm also not talking about Grand Theft Auto San Andreas. There's a fault. We'll talk about what a fault is. Just a
No
second.
mistake?
What?
A mistake? A
Eh?
mistake. A
State?
fault is a mistake.
Oh, mistake. There's a fault that is in California. It's called the San Andreas Fault, and it is a transform boundary. It can create really large earthquakes. We'll see a little bit of that. Okay, so those are the plate boundaries, and you should already know this from last time. So a fault is where earthquakes occur. So all tectonic plate boundaries are faults, but not all faults are plate boundaries. Does that make sense? We have faults here, but we don't have a plate boundary here. Okay. So can we see the fault here in this image? Not the mistake in this image. Frankie, yeah. We can see the fault in this image, right? Here's the fault, this crack, right here. Here is a stratum, right, a layer of rock that used to be one piece. And then as the fault shifts, we can see the difference between the two sides of the fault. Okay. So we have the Wasatch Fault here. But again, we don't live near a plate boundary. We live in the middle of the continent. We do. We live in the middle of the continent. Do we live near an ocean? Taylor?
Yes.
Relatively near to an ocean. We live, what? Like, hours is not a measurement of distance. We live like 900 kilometers or so from the closest ocean.
Only 900. Only.
Yeah, 900 kilometers seems about right. We could find out. Okay. But we have faults here, even though we don't have a plate boundary. The fault line here runs through the earth. Generally, the faults go at an angle, right? The fault goes through the earth here, and I would prefer if you had an image like this in your notes. So what I would recommend is if you're taking notes online or on a computer, I would find an image like this. In fact, it's really easy. Just look for earthquake graphic or earthquake, not graphic. What's the word I'm looking for here? Diagram, earthquake diagram, right? Find an image like this that shows the epicenter, the fault, and the hypocenter or focus. I want you to understand the difference between the epicenter and the focus. So oftentimes when people talk about earthquakes, they talk about the epicenter. The epicenter really is just an imaginary point above the focus, which is where the hypocenter, right, which is where the earthquake actually begins. Okay? So the focus is where the earthquake begins. The point on the surface of the earth directly above the focus is the epicenter. And the focus is almost always right along a fault, because that is where the shift happens. It's where all of it begins. All right? I want you to understand, again, fault, epicenter, and focus, with the differences between those three and what they mean. Because I find that a lot of people just assume that the epicenter is where the earthquake starts. That's not really true. It is the point on the surface that is above where it starts, because earthquakes happen deep down in the ground, a couple of kilometers down generally. and they radiate out through waves. Okay. So they radiate away from the focus or the hypocenter in waves. And there are 4 different kinds of waves that I want you to understand. Okay. If I stop this share, let's see here. Oh, that's not what I meant to do. If I stop the share, pause share. Screen sharing is paused. Resume. I'm confused. I don't know what I'm doing. Apparently I don't got this. Here's what I should have done. No. I want to show me, but I said screen share only in the thing, and that's probably not going to work.
Don't pick it up. Don't be worried.
All right. Let me exit out of this really quick. Just a second, everybody. Give me a second. All right, well, I guess it's not gonna work. Okay. We'll do that in a little bit. All right, so, well, I have a lot of things, windows opened. Holy cow. Get rid of that. And get rid of that. All right. So, when we look at the different kinds of waves, all right, when we look at the different kinds of waves, there are 4 different kinds of seismic waves. Seismic means earthquake. I'm not talking about tsunami. Tsunami are different things. I'm talking about how the energy from the earthquake actually moves through the ground. So there are P waves, S waves, Rayleigh waves, and love waves. P waves,
There's a love wave.
we'll talk about that in a minute. A P wave is a compression and stretching wave. So it is a compression wave. So what I want you to think of a P wave as is kind of like a sound wave as it goes through. It's almost like a shock. And back in March when we had our earthquake here, you could actually feel the P wave. So we had the earthquake here consisted of P wave and S waves. The P wave is just the initial, it's kind of like someone drops something heavy on your floor, right? You can feel it in the ground, right? You can feel your floor like shake all of a sudden when someone drops something on the floor. It kind of is a jolt. It's like hitting something, all right? It's not a long lasting thing. It's really fast and just happens one time. That's a P wave, right? It's a shock wave that emanates away from the focus. The S wave is the second thing that you feel, which is what we felt when we were experiencing the earthquake that Tuesday morning, and you all thought that someone was shaking your bed or something like that. That is the side-to-side motion. It's not hard for me to tell that you're not taking notes. Okay.
Normally I try to take the notes on my own time.
Well, I would recommend taking them on this time because you're here in class, and that's what you're here for. Okay. An S wave is side to side. I like to think of an S as a snake wave. Rayleigh waves are kind of like ocean waves. They're rolling. They go up and down. Okay? And then a love wave. And I'm not talking about the kind of love wave that you send your crush from across the hall.
That doesn't make any sense.
Okay? Love waves are the most destructive kinds of earthquake wave, seismic wave. They're only slightly less destructive than actual bad relationships. Really thought that people would be, you know, entertained by that. I said that love waves are only slightly less destructive than bad relationships. Okay. Oh, LOL, says Taylor. All right. Okay. Yes. P wave, S wave, love wave, Rayleigh wave. The two that I want you to understand the most about, Rayleigh waves and love waves are quite rare. They only happen with extremely powerful earthquakes.
Or extremely powerful bonds.
P wave and S wave occur during most earthquakes, okay? So when we talk about a P wave and an S wave, the P stands for primary and S stands for secondary. The P wave is named the P wave because it is the fastest traveling. It gets there first. Again, it's kind of like a shock. It's an instant, just fraction of a second that you feel something. Again, it kind of feels like someone dropped something in your house. Right? Just really quick. And then the S wave comes through afterward, and that is what causes the rocking and the shaking and the back and forth. P and then S, primary and then secondary.
So much stuff happening right now.
Imagine if we had an earthquake right now.
That would be, yeah, ironic. That would be kind of interesting. Okay. So primary waves, secondary waves. That's what I want you to understand for today. It's not it, but that's where I'm gonna end the video.